These kind of questions have been in the SAT's repertoire for a very long time. I can't quite remember. I think this exact question was from an old practice test that the SAT discontinued when they switched to the digital exam. So I think I've taught it or something like it for a very long time. And I can say confidently that tons of people get this wrong for no good reason. And they get it wrong because they're just thinking about it and they logically pick an answer choice. But the people who get it right and use correct logic feel the exact same level of confidence about their answer as the people who get it wrong by using incorrect logic. In other words, it's impossible to know if your logic is good when you're taking the test, right? You don't know if you're thinking about it right because right and wrong feel very similar. So the advice then is don't use logic, right? I have equations. What do I want to always do with equations? Plug points into equations. Now, I don't see points here, but we can get clever with that and figure out ways to use them. So let's take a look at the story first. The equation above models the number of members M of a gym T years after the gym opens. Of the following, which equation models the number of members of the gym Q quarter years after the gym opens, right? So these equations are supposed to be the same. And we are obviously changing them in some way. So let's see the change happen, right? Let's arithmetize some points to understand how these equations behave. Because your logic might be right, but it's going to be wrong just as often. And so you got to make sure you have methods in place to catch your bad logic. So if you want right now, pick an answer that feels more right. But let's prove that answer right now. Let's make it so that 1 year is going by, right? So that would mean we have 1800 times 1.02 to the first. So I could put that in the calculator and actually get a number, or I can just kind of leave it at that for now and just be like, all right, the right answer is going to also do the same thing. It's going to multiply 1800 times 1.02 to get me the total number of memberships after a year has passed. And how long is a year in quarters? Well, it's 4. So this is going to be Q equaling 4, right? So many of you are going to pick B because you're like, okay, you multiply the number times 4, it's 4 quarters. So a lot of people are going to do this. But if we plug our value in here, notice what happens. We're not raising 1.02 to the first, we're raising it to the 16th. I don't even need to put that in a calculator to know that 1.02 to the 16th and 1.02 to the first are very, very different numbers. So this is the trap. This is what a lot of people think, and they put it very, very confidently on their page. They choose this incorrectly, but they're very confident in that incorrect answer because somewhere in their brain, the logic of multiplying by 4 just seems right. In reality, we need to divide by 4. And even if you thought that, I don't want you to be like, oh, okay, good. I don't need this stupid plug points into equations method. No, you're missing the point. Is you're getting lucky. You got to prove the answer no matter what. It doesn't take much time. And then we can see 1800 times 1.02 to the 4 over 4, which is 1, is exactly what we were doing originally. So we get the same number of members, whether a year is passing or 4 quarters are passing, because they're the same thing. Now we could do the same thing for these choices here. We would see 1800 times 1.005 to the 16th. Again, you could put this in your calculator at this point because now we have a different base number, but these are just not going to behave the way we would want. Let's just try that one just for the sake of it. I don't think it's going to, but 1800 times 1.02 was 1836. So 1800 times 1.082 to the 4th, oof, big number, 2,467, and I think 1800 times 1.005 to the 16th is going to also be insane. Let's see. Well, not that bad. This is 1949, so not unreasonable, but both are also wrong. And there's your proof. So that kind of idea that, we always want to plug points into equations, when we can is really important. We also want to come up with points, arithmetize some points if we don't have them to understand how things are working, because we don't want to think about how an equation works. We want to see it work. We want numbers to test out the equations. So anytime you feel like you're doing a hard math question in the SAT and you're not showing any work on your page, you're opening the door to a trap. Maybe sometimes you'll be right, but you'll be wrong often enough, and maybe on the real SAT you'll be wrong, even if you're not wrong on the practice test. So it's a good habit to get into because you don't want to lose points by surprise. So think about that. Did you get this wrong and not bookmark the question? Because that means you fell for the trap. That means you let your logic lead you and you let a hunch answer the question for you. Prove your hunches right. Prove them with numbers. That's always the best way to approach these SAT questions.